Today we're going to take a look at Chapter 1, Lesson 7, Inverse Relations and Functions. Okay, hopefully you have read the pages in the textbook, and I'm going to go through and kind of summarize what was discussed. Now, we've been talking about functions, and functions are special types of relations. So just to review, a relation is a set of ordered pairs. Now, to find the inverse relation, we switch the x and the y coordinates for each ordered pair in the relation. Okay, so here is a relation on the left-hand side, and this actually represents the function f of x equals x squared plus 1. Okay, so if I plug in -2 for x and evaluate, I'll get 5 for f of x. If I plug in -1 for x, -1 squared is 1 plus 1 is 2. If I plug in 0 for x, I would get 1 for f of x. If I plug in 1 for x, I would get 2. And similar, if I plug in 2, I'd get 5. So the graph in the blue, the quadratic, okay, is the graphical representation of this relation on the left-hand side. Now, to find the inverse relation, you take each ordered pair for the original and you switch all of the x and the y values. So -2, 5 becomes 5, -2. -1, 2 becomes 2, -1. 0, 1 becomes 1, 0, and so forth. Okay. Now, if we go through and we graph the inverse relation, which I have done here in the pink, notice it also makes a U-shaped curve, but it is opening up to the right rather than opening up. Okay. Now, when we find the inverse relation given an equation, you switch the x and the y values. So where this was y equals x squared plus 1, the inverse would be x equals y squared plus 1. Okay. And you can see what it looks like numerically. You can see what it looks like graphically. Okay. Now, all inverse functions reflect over the line y equals x. When we have the graphs of relations and their inverses, we're going to focus on whether the original function and the inverse are functions. So, is this relation a function? This was the original quadratic, and yes, it is, because it passes the vertical line test based on the graph. On the ordered pairs, no x values repeat. For the inverse is not a function because the graph of the inverse does not pass the vertical line test. And if you notice for the inverse, I have x values 5 and 2 that repeat. So the original relation is a function, the inverse is not a function. Now, we are going to focus on relations in which both the relation and the inverse relation are functions. So we call this a one-to-one function. So a one-to-one function are functions whose inverse is also a function. So this relation, f of x equals x squared plus 1, okay, this is not a one-to-one function, okay, because although the original is a function, the inverse is not a function. Now, we have a test for a one-to-one function, and one-to-one functions are functions whose inverse is also a function. We use the horizontal line test to determine if a function f of x has an inverse function, and this is the notation for the inverse, f inverse of x. Okay. Now, our original inverse does not pass the horizontal line test because if I draw horizontal lines through the blue curve, okay, it touches the graph more than once. So this is not a one-to-one function because if we just verified, the inverse is also not a function. Okay, now just a bit of information. A function that passes the horizontal line test is a one-to-one function. A one-to-one function is a function such that no two elements in the domain correspond to the same element in the range. In other words, no y values repeat. Now, the domain of a one-to-one function is the range of its inverse. Because remember, to find the inverse, you switch the x and the y. So if we switch from domain to y, that's the range. Similar, the range of a one-to-one function is the domain of its inverse. Now we're going to turn the page and we're going to look at two examples to determine, using the vertical line test and the horizontal line test, first if we have a function, and then second if we have a one-to-one function. Okay. Go ahead and turn the page. Okay, let's look at example number 1. We are going to graph the equation y equals 3x minus 1. This is a linear equation. The y-intercept is -1. So I'm going to plot a point at -1 on the y-axis. My slope is 3. Let me repeat that. My slope is 3. To make the slope a fraction, we put it over 1. So it's a +3 over a +1. So from our y-intercept, I would count up 3, right 1, up 3, right 1, up 3, right 1. I could also go down 3, left 1, down 3, left 1. Okay, and then I have enough points. I like to use my ID or a ruler as a straight edge so I can make a nice picture. And I have graphed the linear equation. Now, is this a function? We're going to use the vertical line test and we're going to use the horizontal line test to look at the next two questions. We use the vertical line test to determine if it's a function. So every time I draw a vertical line, it passes through the curve just one time. Therefore, yes, it is a function. Now, is this a one-to-one function? Okay, I'm going to use the horizontal line test. So that means for every horizontal line that I draw, it passes through the curve exactly one time. Therefore, yes, this is a one-to-one function. So what that means is if I were to graph the inverse is also a function. Now, I'm going to have you try the next problem. I want you to graph the quadratic and determine whether it is a function and a one-to-one function. Pause the video. When you're ready, hit play, and I will go through this example with you. All right, we have to graph y equals x squared minus 4. Okay, this is a quadratic function based off the parent function y equals x squared that is shifted down 4 units. This is all information that you've learned in both Algebra 1 and Algebra 2 that we need to recall and apply to pre-calculus. Unfortunately, we do not have the time in pre-calculus to learn how to graph all the functions that you've learned in the previous classes. So if you are starting to struggle on graphing some of the basic algebraic equations, you need to make sure that you pop into SRT and get caught up so that you can make some basic curves. All right, so the vertex is at 0, -4 because the parent function has a vertex at 0, 0, which is y equals x squared. The -4 means it was shifted down 4 units. So I have a vertex at 0, -4. Okay. Name the zeros. Okay, we learned this earlier in the chapter. We replace y with 0 and we solve for x. So we have 0 equals x squared minus 4. We add 4 and take the square root, which will result in 2 answers. Okay, the zeros are at 2, 0 and -2, 0. Plot those points and I have enough to make the quadratic. Is this a function? Yes, because it passes the vertical line test. Is this a one-to-one function? No, because it does not pass the horizontal line test. All right, I'm going to stop this video after example 1 to give you a moment to kind of look and process. When you're ready, I'm going to have you go to the next video in which we will look at examples 2, 3, and 4.